Hello everyone and welcome to the session 4 of week 12 of NPTEL course in pharmacognosy and phytochemistry. This week we are learning little different topic from what we usually study in our syllabus, and those are using computational based techniques, computational databases as well as certain servers which help us understanding the plants, their applications as well as their physical as well as chemical properties. So far in this session you have learned different databases that can help you identify the plants. This include your Plants World Online, Gestor, Tropicos, New York Botanical Garden. There are many more paid and unpaid softwares, but this being freewares and rich in information, we are very conversant with this right now. The next session we saw what are the different softwares or databases or web-based servers which help us in understanding the traditional medicinal preparations. So we saw TKDL, Traditional Knowledge Digital Library, which had all the traditional formulations with their ingredients, procedure, preparation. We saw IMPPAT, where even the traditional medicinal plants, their geography and phytochemical search was obtained. We also saw the Indian Medicinal Plant Database, which gave us more about the plants, their occurrence, their information as well as different applications, including the shlokas and the Ayurvedic text which had it. Thereafter we saw in our previous session, if you recollect, phytochemical search. So through which once you know the plant, once you have shortlisted the plant, be it a kind of a herbal medicine or be it a traditional medicine, you can easily search what all compounds are present using these all databases. The few databases that we studied included Dr. Duke's Knapsack, PhytoHerb, Coconut, IMPPAT as well as Osiri database. Now in today's session, we are going to go a step forward, and that is whenever you purify these compounds from your plant sources, what happens there is you have a compound at hand, and then the question is I have to analyze it to ascertain its purity. So far using the quality control methods, we saw that definitely my HPLC, my GC can help me ascertain the purity. But you for identity, that is for establishment of identity, you require to resort to not only chromatographic but also spectroscopic method. Now many a times your LC, that is HPLC, or GC, that is your gas chromatography, is often coupled with mass spectroscopic. So your HPLC as well as GC is coupled with mass spectroscopic detector, which gives us MS fragments, and thanks to the advances in machine learning techniques, we now have a library search wherein this mass fragments are analyzed by computers, and the computers come up with the possibility that probably this is the plant you have and this is the compounds that are present with it. Now, given a case due to some incidences you purified a compound and maybe you want to see whether it matches or not, or you have an intention to purify one compound. Say for example, we have been dealing our search with quercetin. So let's put a quercetin example here. So tomorrow I say from all the sources that my previous software gave me, I tried to purify quercetin, and to certain extent I have a molecule in hand. So now what I have is a yellow color powder. Now I give it or I subject it to my mass spectroscopic technique. Now many a time we as students or academicians even struggle with spectroscopic data. So in order to facilitate this, there are also databases which help us give us spectral information. So even if we don't know the spectral data, you can put in the structure of the molecules in this spectroscopic databases, and what you will find is because you put your structure in this databases, now you are getting a well resolved data and the peaks also have the meaning. So let's see what all databases there are. Few databases that we are going to study today include here your spectra base, IR spectra prediction, you also have your NMR spectra prediction, then you have your biosynthetic pathway. Now biosynthetic pathway prediction is not clearly prediction, but I wanted to show you, or I brought in this also just to tell you that it is also possible for me to put my metabolite in a particular pathway and trace back where it came in from. So initially we will see different structural properties, but at the end, towards the end of this session, we will also see that there are softwares which will tell me from where or which pathway is my compound biosynthesized. So let's study these pathways one by one. So we go to the first pathway, and our first pathway is a spectra based pathway. Now this spectra based pathway gives you a quick access to numerous molecules. This is a Wiley based search engine which has stored data of numerous compounds, and it not only gives you an idea about it, but it also gives you some references pertaining to where this data is taken from. So you can get your NMR, IR, Raman, UV-Vis, or in certain cases even mass spectra. But since this is a server base for compounds whose spectroscopic data is not available, you might not find the query coming back with all the answers. So in some cases a complete database, that is NMR, mass, IR, may be ready. In some cases you might just get up one or two. Okay. So this, let's quickly try to search our same molecule, and that is quercetin. So when I put my query as quercetin, the spectra base is suggesting a molecule. It is also trying to give me analogues. So these are all the compounds that it has come up with. So not only you will get quercetin, you will get all over searches or hits wherever this word is quercetin, even if it is a sub part of the name or the nomenclature. So let's see our molecule quercetin. So this is quercetin dihydrate, and this is your quercetin. I am just clicking on this. So you can see here it has a good databases. It has about 81 NMRs, 2 FTIRs, 2 UV-Vis graphs, about 15 GC searches and 2 MS searches, which you can access through this. So this is the IDs. The molecular weight is about 302. So just going to proton. It will give you an option, view full spectrum for free. Click on it. Okay, it will ask you to log in maybe. So after entering your registration or after registering in, as you can see, you are able to access the spectral data. You can zoom it, you can unzoom it. These are mostly your hydroxy protons out here. So now when we go back, let's try to see if you are able to visualize the C13 NMR as well. So just clicking on it, and you can see there is some idea about it. Let's view the entire spectra, and after logging in again you will be able to see the entire NMR spectra of quercetin. This is the C13 NMR spectra. Let's move to the IR. Let's click on the IR. And you can see a reverse IR spectra of this with the fingerprint region as well as a very sharp hydroxyl region for your quercetin. So the point is, through this one software, when you kind of log in, you will be able to get most of the data associated with it. So you got your NMR data, you got your IR data. You can also see the stored or saved, like this is a server, so this is definitely collecting it. You can see the UV-Vis. Now you know it's a typical flavonoid, so you should see two major peaks, one representing your band 1 if you recollect, and this one representing your band 2. So these are the saved peaks. It's also given the solvent in which they have been obtaining this. So all in all, based on this data, it will generate values for you, it will generate a graph for you. So you will get whatever readings you want in terms of that. The mass spectra showing its mass as 302 if you recollect. So my point is, if you're not conversant in spectroscopic techniques, this database will kind of give you some reference values to compare with, and basis those reference values, when you compare your spectra, you will come to know if the peaks are overlapping or not. And based on that, you can take a call whatever compound you have isolated is actually quercetin or not. Similarly, there are other databases or other interesting databases for IR prediction, and this is another one which is from ChemInfo. Now here you will see that in ChemInfo again we can draw the structure. We will create a flavonoid quercetin again, and let us see. So I am just putting the oxygen groups now. So I raise my query, and this is a simulation based software. The ChemInfo is going to predict based on its structure and attributes, and let us see how it predicts. So definitely it has come up with a spectrum. So you can see again a fingerprint region as well as the hydroxys region, but rather than a proper band which appeared in the previous software which gave you as much as a natural spectra as possible, instead of a bands here you will observe discrete lines. That is the difference here. You can see every time I move this cursor, a molecule gets highlighted. Now the interesting part of this software is, now in addition to giving you values, you remember IR spectra principally happens due to stretching, bending, tailing, wagging, kind of vibrations between the molecule. And if you are not conversant with it, this software is very interesting way to learn. Say for example, I want to see here that the vibration or the band which is appearing at 3,5 is due to what, and you can see carefully here, this is what is moving. You can see here, this is what is moving. So it is telling it's basically the wagging action of this hydroxyl group which is giving me this band. This is the stretching. So I can take my cursor on every value and what or why exactly that reading is coming. So you can get it basis this structure, or you can get basis this molecule. You can see in both manners. So I am just putting it here, and you can see when I click here, it is due to which regions, which interactions, that is also seen, and what exactly is happening, that is also seen. So in the fingerprint region you will see mostly the whole molecule is involved, but beyond fingerprint region, if you go to specific wavelengths or little higher wavelengths, you can see this is due to hydroxy, CH. You remember your carbonyl which occurs somewhere around your 15 to 17 centimeter inverse. So let us try and search if that is the case. So these are mostly the double bond ones, and see, you can see here. This is the carbonyl interactions. And these are the hydrogen interaction. I just click on it, you will see the interactions on the top molecule as well. So if I see this, you can see what exactly is due to interaction and the hydrogens involved. I just need to keep my cursor here. This is the typically carbonyl interaction with the adjacent hydrogen. That is what is happening. So this database, that is the cheminfo.org IR database, will give you a very nice structural representation of IR spectra, and you will be able to understand the peaks in a much nicer manner. Similarly, if you go to the ChemInfo NMR spectra, you can also get much more depth as compared to the Wiley one. So again I am putting my query as quercetin, and let us see what ChemInfo has to offer in terms of NMR. So I run this queries and I ask ChemInfo to simulate my NMR spectra. So you can see here, as compared to the previous ones, here you get the coupling values. So that one was very predictive. This one is more of analyzing. So you know which proton is coming where and how. So you can nicely move this, and you can see this is the proton of quercetin which is at the 6th position. This is the proton which is at the 3rd position. So if you want to convert it into hydroxy for quercetin, you might do that. I kind of missed it there. So again you can see here this particular ones. Now flavonoids have most of the molecules which are aromatic. So you will see all the proton NMR peaks come in between to your 6 to 8 ppm. Now what if I want to increase it? You can even increase the resolution of this. Now you can also add here, or you can change the moles of this. So under the spectra tab, you just go in the prediction and then you say all NMR predictions. So it is going to give you all different NMR predictions. This includes your proton, C13, COSY, even your 2D, that is HSQC, HMBC and so on. It's still calculating. So let's try predicting it one by one. Let's say C13 prediction. That will make it a little faster. So you can see here all the carbons are accounted for. Which carbon and what is the value. So you remember typically your carbonyl comes at 180. So that is how you try to match it. So depending on that, all your C13 values. So now that you have your spectra, you can correlate. You can see whatever I am highlighting here is also simultaneously highlighted as a red line in the below spectra. So you will see the peaks of each of these carbon compounds. It's occurring in sequence. So you need not worry which is your adjacent carbon. Now going to the B ring. So all the adjacent carbons it will account for. It will give you a reading. So you can just pick up this NMR value and compare with those reported in your literature articles. We will also see the 2-dimensional if it is able to predict. So let's try HSQC. So you can see you can get your 2-dimensional proton and C13 NMR in a HSQC manner. So it's still loading, that's the reason it's taking time, but you can see the peaks out here. So it not only helps you with 1-dimensional, it also gives you a good in-depth spectroscopic details about your 2-dimensional NMR spectra. Let's try a COSY. You can see a correlation is obtained, so you come to know which is adjacent to what. So your correlation spectra is also obtained with a proton 2D manner map superimposed. So this is the software that can tell you about your, that is ChemInfo, gives you much detail about your mass, NMR as well as IR. The good part is with the mass it gives you the fragmentation pattern, with the IR it will tell you the peaks, and with NMR it will tell you the ranges as well as the coupling constants. Another way to predict is what is called as the NMR database, which gives you the almost similar thinking. So here again we have to just draw our molecule. You can see the interface is very much similar. So I'll just draw a little different molecule now. And let's see. I'm drawing coumarin. So it's the very same database it is connecting us to. So the NMR DB is also obtained through this, and it's the very same interface, so you can see the values. So you can either go by what is called as the ChemInfo database, or you can go by NMRDB. The interacting interface is one and the same. Now we go to the last part where I told you that in addition to spectroscopic data, your databases interestingly also tell you about the biosynthetic pathway of your metabolites, and this interesting pathway finder is what is called as your KEGG database. So in that I can just insert my molecules and see that what biosynthetic pathway they originate from. So let's bring in a variety now. Let's try to put in maybe quercetin or tropane. Let's try tropane. So I'm just it's coming up with a huge biosynthetic pathways, different biosynthetic pathways, and where all your tropane will feature in that. So this is one, you can see. I'm just clicking them one by one. You can see from your glucose, that is your glycolysis, slowly to your Krebs cycle, you can have most of your glycosides being synthesized. Just moving on this side, you can see it has gone to cuscohygrine, hygrine, tropinone, tropine, and from that it came into your tropane alkaloids. Here also this includes your hyoscyamine, hyoscine, cocaine and tropane and so on. So this is one. So here it is not containing structure, but if you see here, it is kind of a pathway that is depicting the biosynthesis of most of your alkaloidal compounds. And here you have in your biosynthesis, if you go from this biosynthesis, or if you come in here, you can see slowly you get your tropinone as well as tropate. So tropinone and tropate will give you a tropin. So this is where it is. You will see your other alkaloids also coming in this pathway. So KEGG software kind of gives you an idea about the biogenesis of your metabolites. So what we saw right now is there are techniques that will help you analyze the spectra, or there are techniques which will help you analyze the compound by using spectroscopic techniques. So once you have your compounds, now no matter if you are little weak in spectroscopic techniques, what you can do now is that the databases we have learned, you can search in for your compounds, you can obtain the mass, NMR, IR values and then compare with the ones that you have obtained. If the values are exactly overlapping, plus minus little error, because these are mostly computational values, there is a good chance that your compound is pure. But if you are getting additional peaks, there are chances that it might be impure or it might be some other compound. So with this, we end our today's session. Thank you everyone, but don't forget to try this spectroscopic databases for analysis of different metabolites that we studied in the previous week. Thank you.